4 minutes ago, a signal left a spacecraft that is currently farther from you than any human-made object has ever been. It won't arrive here for almost a full day, and when it does, scientists at NASA are going to spend weeks trying to explain what's inside it. Because right now, they can't. This is the story of a machine that turned around once, 36 years ago, to take one last look at the only home it would ever know. And what it has found since then, in the cold dark it flew into afterward, is something that no model, no simulation, and no scientist predicted it would find, something that is still happening. Right now, as you listen to this, its name is Voyager 1, and its story is not finished. In February of 1990, when Voyager 1 was about 7 billion miles from the Sun, mission scientists made an unusual request. They asked the spacecraft to rotate its camera back toward the inner solar system, back toward everything it had left behind, and take one final photograph before its imaging system was shut down forever to save power. The result was a single frame, barely more than a smudge of light caught in a stray sunbeam. Inside that smudge was Earth. Every person who had ever lived, every war, every love story, every sunrise anyone had ever seen. All of it contained in less than a single pixel. Carl Sagan, who pushed for that photograph to be taken, called it the pale blue dot. He said it was a reminder of how small, how fragile, and how alone we really are. That was the turn. The last time Voyager 1 looked back. Since then, it has not stopped moving forward. It has been flying blind for over 3 decades. Its cameras dark, its instruments stripped down year after year to conserve the last drops of power from a nuclear battery that was never designed to last this long. And in that darkness, without eyes, using only instruments built to sense magnetic fields and plasma waves, Voyager 1 has been sending back something far stranger than a photograph. It has been sending back the sound and structure of a place no human instrument had ever touched. And what it found there is still not fully explained. Let's talk about where it actually is, because the number alone should stop you. Voyager 1 launched on September 5th, 1977, riding a Titan IIIe rocket off the coast of Florida. It flew past Jupiter in 1979 and Saturn in 1980, using Saturn's gravity to slingshot itself up and out of the plane of the solar system onto a trajectory pointed directly away from the Sun. The mission was built to last 5 years. It has now lasted almost 50. Today, Voyager 1 is more than 25. 8 billion kilometers from Earth. That is not a typo, and it is not an exaggeration. Light, the fastest thing that exists anywhere in the universe, takes nearly a full day to cross that distance. In November of 2026, Voyager 1 will become the first object built by human hands to reach a full light day from home. Nothing else we have ever built has traveled that far. Nothing else will, for a very long time. In August of 2012, Voyager 1 crossed a boundary called the heliopause, becoming the first spacecraft in history to leave the heliosphere. The vast magnetic bubble carved out by our sun that shields the planets, the asteroid belt, and everything we have ever directly explored from the raw radiation of the galaxy. Crossing that line meant leaving the protection of our star behind entirely and entering interstellar space, the region between star systems, for the first time in human history. And that is where the story stops being simple. Because the interstellar medium was supposed to be quiet, empty, a uniform, featureless void between the stars, the kind of nothing that fills the gaps in every diagram of the galaxy you've ever seen. That was the model. That was what nearly every scientist expected Voyager 1 to confirm once it crossed over. It did not confirm that. It confirmed the opposite. Since 2017, Voyager 1's plasma wave instrument has been picking up something scientists did not expect to find out there. A persistent, structured signal, a kind of steady hum in the plasma surrounding the spacecraft. In 2020, researchers isolated it clearly enough to describe it publicly for the first time, the hum of interstellar space. A continuous, low oscillation in the density of charged particles, present in the data the entire time, just waiting to be found. It wasn't triggered by a single event. It wasn't an echo of a solar storm. It was simply there, a baseline resonance in the fabric of the space between the stars, a frequency that no instrument in human history had ever been positioned to detect, until this one machine, built in the 1970s to study gas giants, happened to fly directly through it. Space, it turns out, is not silent. It hums. But the hum was only the beginning. Starting around 2020, something else began showing up in Voyager 1's readings, something that has kept mission scientists occupied ever since. The spacecraft's magnetometer and plasma instruments began detecting a sustained increase in magnetic field strength and plasma density in the region it was passing through. Not a spike, not a single anomaly that came and went. A prolonged, elevated reading that Voyager has now been flying through for years, without a clean, expected explanation. Some mission scientists have proposed something almost hard to say out loud, that Voyager 1 may have entered a small ancient cloud of interstellar plasma, a relic, a kind of cosmic scar tissue, left behind by a star that died or a star-forming region that erupted, possibly millions of years before our solar system even existed. If that theory holds, it means our entire solar system right now may be moving through or brushing up against the ghost of something that happened in this part of the galaxy long before humans, long before Earth had an atmosphere, long before there was anyone here to notice. Think about what that actually means. It means the environment surrounding our solar system, the thing our models confidently described for decades, is not what we thought it was. It means the protective bubble around our entire solar system, the heliosphere that shields Earth from galactic radiation, might be interacting right now with structures we never accounted for. It means the boundary between us and the rest of the galaxy is not a fixed, static line on a diagram. It is a living, shifting frontier, shaped by material that has been drifting through the dark for millions of years, and we only know about it because one small, half-century-old machine happened to fly straight through it with just enough power left to tell us. And here's the part that should genuinely unsettle you. We still don't fully know what it is. The readings are real. The elevated magnetic field is real. The density increase is real. But the explanation, what this region of space actually is, how far it extends, what it means for the long-term structure of our solar system's shield against the galaxy, that part is still being worked out, argued over, and re-examined right now in 2026 by scientists staring at data pulled from 25 billion kilometers away, trying to make sense of something nobody built this mission to find. That's the discovery nobody can fully explain yet. And it's still unfolding, transmission by transmission, as you're hearing this. Now here's what makes all of this so much harder, and honestly, so much more human. Voyager 1 is dying, slowly. Not with a dramatic failure, not with an explosion or a crash, but the way old machines die. One system at a time, in the quiet, patient way that physics eventually wins against everything we build. Both Voyager probes run on radioisotope thermoelectric generators, essentially nuclear batteries that convert the heat from decaying plutonium into electricity. There's no sunlight to draw power from out there. The sun is just another star in the sky by now, too faint and too far to matter. Every single year, each spacecraft loses about 4 watts of power. 4 watts doesn't sound like much until you understand that after nearly 50 years, there's almost nothing left to lose. Every remaining watt is fought over by every remaining system just to keep the spacecraft warm enough and pointed accurately enough at Earth to keep the signal alive at all. On April 17th, 2026, engineers at NASA's Jet Propulsion Laboratory made one of the hardest calls of the entire mission. They sent a command, one that would take almost a full day to arrive, instructing Voyager 1 to permanently shut down an instrument called the Low Energy Charged Particles Experiment. It had been running almost without interruption since 1977, 49 years of continuous data. It was one of the instruments responsible for detecting the very boundary crossing into interstellar space in the first place. Now it's off, permanently, unless something changes. Voyager originally carried 10 sets of scientific instruments. 7 have now been shut down one by one over the decades, just to keep the spacecraft breathing. Only 2 remain active, the magnetometer and the plasma wave subsystem. The same instrument that first caught the hum of interstellar space. The same one still recording the anomaly nobody can fully explain. The decision to cut the LECP wasn't made casually. On February 27th, 2026, during a routine maneuver, Voyager 1's power levels dropped unexpectedly. If they had dropped any further, the spacecraft's automatic fault protection system could have triggered a self-preservation shutdown that carries its own serious risk of the spacecraft never fully recovering. So the engineers made the call themselves, on their own terms, rather than risk the machine making a worse decision on its own, 25 billion kilometers from anyone who could help it. Voyager 1's project manager, Suzanne Dodd, has described the current state of the spacecraft in blunt engineering language that says everything you need to know about how fragile this all is. Everything on board, she said, is now single string. No backups. No redundancy. If one of the remaining thrusters fails, and the ones responsible for keeping that fragile antenna pointed precisely at a planet 25 billion kilometers away, the signal doesn't degrade slowly. It just stops, permanently. And that signal, even at full strength, is almost nothing to begin with. Voyager 1 transmits data at a rate of about 160 bits per second, slower than a dial-up modem from the 1990s. It takes some of the largest radio antennas ever built on Earth just to pull that whisper out of the background noise of the universe. Every command sent from Earth takes close to 23 hours to arrive. The response takes another 23 hours to come back. A single question and answer, the simplest possible exchange, takes almost 2 full days. There is no room for a quick fix. Every mistake costs another 2-day wait, just to confirm. Between May of 2025 and February of 2026, the only antenna on Earth capable of sending commands to both Voyager spacecraft, a massive dish in Canberra, Australia, went offline for upgrades. For most of that stretch, engineers could receive Voyager's data, but they could not talk back. They could listen. They could not act. It was one of the most anxious periods in the mission's recent history, watching a dying, irreplaceable spacecraft from 25 billion kilometers away and being unable to do anything but wait. The moment that antenna came back online, the very first thing the team did was carry out the LECP shutdown they had been reluctantly preparing for months. But this is not simply a story about a machine slowly running out of options. Because right now, engineers at JPL are preparing something they've internally nicknamed the Big Bang, a bold, high-risk maneuver that would simultaneously power down a group of systems and swap in lower-power alternatives, buying the spacecraft more time by trimming its electrical appetite in one coordinated move. It's essentially open-heart surgery performed at the speed of light on a patient 25 billion kilometers away, where every incision takes 2 days just to confirm whether it worked. The plan is to test it on Voyager 2 first, since it has slightly more power to spare and sits somewhat closer to home. Those tests are planned for May and June of 2026. If they succeed, the team intends to attempt the same maneuver on Voyager 1 no earlier than July 2026. And if that works, if the Big Bang actually succeeds, there's a real chance the very instrument that was just shut down, the LECP, could be switched back on. The eye that just closed could reopen. Matt Hill, the principal investigator for that instrument, put it simply: the team is holding on to the hope that they'll be able to power it back up and let it keep revealing whatever surprises are still waiting for Voyager out there. That word, surprises, carries real weight because interstellar space has already surprised nearly everyone who has studied this data. And by every indication, it isn't finished. Even in survival mode, stripped down to 2 working instruments, Voyager 1 keeps making discoveries no one anticipated. Its plasma wave instrument has picked up pressure waves from solar storms, eruptions on the surface of our sun that traveled billions of kilometers through the emptiness and rippled measurably against the spacecraft, years after they were first unleashed. Our sun, it turns out, reaches much farther into the darkness than anyone assumed. Its influence doesn't simply stop at the edge of the solar system. It echoes outward, shaping the structure of interstellar space itself in ways we are only now beginning to measure. If the current plan holds, engineers believe the recent power-saving measures should buy Voyager 1 roughly another year of operation, just enough, they hope, to reach the 50th anniversary of its launch in 2027, half a century. A spacecraft designed to survive 5 years, reaching 50, from a place so far away that light itself needs a full day to travel the distance back to the world that built it. Beyond that, nobody can say for certain. The radioisotope generators may keep supplying just enough power to return basic engineering data until sometime around 2036. But that is the outer edge of hope, not a promise. Every year between now and then depends on thrusters that have no backup left, on fuel lines that must not freeze, on fault protection systems that must not misfire, on a 49-year-old machine continuing to do something it was never built to do this long. That is a lot of ifs, resting on a spacecraft older than most of the engineers currently keeping it alive. And there is no second chance waiting in the wings. There is no Voyager 3 on a launch pad, ready to take over. NASA has discussed a dedicated interstellar probe mission for years, but as of 2026, it remains only a concept, unfunded, unbuilt, decades away from ever reaching this same boundary, even if approved tomorrow. Which means if Voyager 1 goes silent, humanity doesn't simply lose one spacecraft. We lose our only direct window into this region of the galaxy, with nothing built to replace it for a very long time. That is what makes every single transmission that still arrives so remarkable. Every one of those faint, 160 bit per second whispers, arriving after a 23-hour journey through nearly 26 billion kilometers of empty space, is data that cannot be replicated by any other instrument that exists anywhere. It is a message from a place none of us will ever go, sent by a machine that has already outlived every reasonable expectation placed on it, still working, still listening, still turning the raw hum of interstellar plasma into something scientists on Earth can study, argue about, and slowly begin to understand. Voyager 1 also carries something beyond its instruments, a golden record containing sounds and images of Earth, greetings in dozens of languages, music spanning cultures and centuries, the sound of wind, rain, and a mother's heartbeat. It was placed on board as a message in a bottle, cast into a cosmic ocean nobody expected humanity to ever actually explore firsthand. And now, decades later, that same spacecraft is sending something back the other way. Proof that the ocean beyond our shore is not empty, not simple, not what any of us assumed it would be. We used to think the space between the stars was silence. Voyager 1 is telling us, one faint signal at a time, that we were wrong. And somewhere out there, right now, 25. 8 billion kilometers away and drifting further every second, a machine built in the 1970s is still doing its job, listening to a universe none of us can hear, and sending home whatever it finds, for as long as it possibly can.